For this lesson, we will introduce the concept of a function. And one of the best ways to approach this right now is we've already seen a couple functions. We've seen main itself, which we call the controlling function, and we've seen this one. This one also is a function called system. So the name right before the parentheses is the actual identifier of the actual function name. And usually you want to give a name to a function that is meaningful in terms of what does this function do. In our case, for example, main is called the main controlling function. You're going to need that in a C++ program, in a Java program, in a C program. So it is a function where when your program starts, your first line of code where it gets executed is always within main, or the controlling function. And then by the time you get out, your last statement, when you hand over control to the operating system, is typically also done within the function main. Okay? Other functions, like this one, system, this, for example, takes an argument, right? So you're going to see different flavors and different ways to express a function. So whatever you write between the parentheses, it's either called an argument, okay? Or it's also called a parameter. It all depends on how you're using it, at what level. Are you calling the function or defining the function, okay? So in this case, this is an argument. I am giving it a string as an argument to handle. And what it is I am telling it to go to the operating system and run the command pause. Okay? So for example, let's say, let's see what that is. So if I do CMD, right? So CMD takes me to a Windows console, right? And in here, I can type something like pause. And let's see what that does. Press any key to continue. And that is exactly what pause does. It's a what we call a DOS command, or a disk operating system command. So we've seen it in the previous example with the calculator, where we also used clear, or CLS, right? So you can actually clear the screen. So it is a job that we want this function to do. Can we have it do it several times? Absolutely. So, and that's the advantage of having a function, is you can have it do it as many times as you want. Which means, can I have it in a loop as well? Of course you can, right? So let's see here what happens if I call this function 2 times. So this, what you're seeing here, is what we call a function call, right? So within main, we're calling this function system, and we're supplying it with an argument, right, that it accepts as a parameter. And in that particular argument is a command pause. So let's see what this program will do. So let's compile and run. Of course, it's going to run this on the console. Notice I have a press any key to continue. Let me make this a little bigger for you. And let's go over here. Right? And now if I press any key to continue, watch what happens. It will ask me again, press any key to continue. When I press the key, say the space bar, for example, then it would have completed the second function call, and named system, with the argument pause. And then what would happen is you will be executed the return 0, which is the last instruction within the function main, where 0 is returned back to the operating system, which means that's really the last line you want for main. So notice now, within the function main, we have the keyword return, and return a value. What kind of value? You write that down when you're defining the function right here. Okay, so this here is what we call a function definition. And what we're doing is we're saying that this function's template, or the way it's going to work, it will return an integer when it's done. When you're done using main, it will return an integer. Hence the keyword return at the end here. And what is it going to return? It's going to return a value that is of type integer. Fantastic. So, what does this return? Okay, well, this will execute a line. It doesn't necessarily need to return anything. Notice this is not a function definition. This is a function call. This is how you would call system. Okay, can we have now custom functions other than what we've seen with main and system? The answer is absolutely. So let me just clean out this one, just leave one in there. And let's create our own. And watch this. Void, there's another way to do this. And we're going to write the function definition right here. So void my function. So you can name it whatever you want, but typically you want the name of the function to represent what it does. A lot of people like to write verbs for function names, okay? Because it's typically associated with an action. But for our example, for the sake of what I'm doing here, is I'm creating a custom function. Notice the return type is void. That means this one does not return anything. That means when you call it, you can simply call it and don't expect it to return anything other than execute what it's supposed to do. Notice I'm not going to put any parameter right here, so that means it will not accept any arguments. Okay, and I'm going to open the curly brace and close the curly brace. So what I'm doing here is, again, a function definition, and this one happens to be a custom function definition. This is not part of the language, right? So where main is part of the language, how about system? System is not part of the language. Actually, system comes in because you've included a library that supports it. Okay? Just like the math library. Remember CMath? I was able to use the sine and cosine functions, or POW for power, right? Those were functions, and they were defined within the math class, CMath for C++, or math.h for C. In our case, system has been defined already for us in IOStream, so I don't need to redefine it. But if you're creating your own functions, you're going to have to say exactly what you want it to do. So for example, I want this one to say, hi there. Put a new line there, and here you go. And all it does is prints hello there, right? Or something like that. Now notice where I defined this function. I defined it before main. Okay? So that means now when you compile this, your program or your compiler is going to know this function exists, which means it needs to write the machine code associated to this function as part of your executable file at the end, right? So this is part of the compiling. It's going to be included. So now let's see what happens when you compile this. And notice when I compile it, I get no errors, no warnings. Now let's suppose I wanted to define this, right? So let's say I want to define this after main. Let me cut it and do it right here after main. Okay? So let's compile it again. Okay? Now it happens that my compiler is accepting it, but that is not the proper way to do it. If you want to define it after main, the best way to do this is you're going to have to write what we call a function prototype. So how do you do this? You write the signature of the function, void my function, and you do not put curly braces, just put a semicolon. This tells it to expect that function to be defined after main. This is what we call a function prototype. So we're learning a lot right now. We're learning about function definitions, function calls, and function prototypes. Prototype. So let me just write it up properly here. It's not going to run this function at all. This is simply telling the compiler, expect this function to be defined within this program after main. So in case you wanted to define this function after main, this is where it happens. Okay, so let me compile and run and show you that hi there is not going to appear anywhere, right? So simply anything you're seeing is right now whatever you called from main. Aha! So now how do you use my function? You simply call it from main. My function. And how do you call it? Just like we did with the function call for system. Semicolon. Notice it does not take any arguments, so that is the way I defined it, right? Technically, what you have here is a void and void. This is the formal representation of having nothing between the parentheses. And again, you could use the void to say, I am returning nothing. Okay, so let me just compile this for a second here. All right, as you can see, that is correct syntax. You can omit the void here, and you can omit the void here, but do not omit the return void here. Notice that I don't have a return statement for my function, unlike main. And the reason for it, again, is because I have the keyword void. Now, let's see what happens when you call the function. So we know this one is also a function call. Let's see what happens. So compile and run. And notice now we get hi there. Okay? So can we call this function several times? Absolutely. My function. So this spares us from rewriting code. Hi there several times. Simply call the function. When you need that job to be done, call it. Let's see what that does for us. So compile and run. And notice it says hi there twice. Okay? Can we put it in a loop? Absolutely. So we could say something like this. Int count equals 0. You could do something like this. And let's clean up this one here. We're going to do this 10 times. While count is less than 10, we're going to do a couple things here. Go ahead and call my function. Okay? And make sure you increment your counter, otherwise you'll never get out of here. Why? Because you want to make sure that the while loop will test false after you've reached 10, right? So from 0 to 9 will be okay. Once the count goes to 10, right? You're on your 11th count, since remember you're starting at 0. Okay? All right, notice here I specifically said less than 10. We know the count by the time you're here at the end will be 10, which means when you reevaluate for your while loop, that would be it will be false. So this is still a function call, except I'm doing it 10 times without writing it 10 times myself. I put in a loop. So let's see what happens. So compile and run. And notice here, hi there is 10 times. Okay? So it's pretty cool. So you can actually call a function as many times as you want, right? Without rewriting hi there yourself within your code. Okay, now this happens to be a simple program. What happens if you have a much more complex algorithm that requires that you repeat it over and over and a few changes happen and you're observing that? Then function calls are your best bet, okay? So what are the 3 things we've learned? Function prototype. That means let the program or let your compiler know that you're going to be defining this function sometime after main. If you do not want a function prototype, then I highly recommend that you define the function before main. So let's, again, go through this. So let's say you don't want to do this. Then I want you to cut this and paste it above main. That would be the proper way to do things. So this will work as well. So let's compile and run and show that. Okay, perfect. So same results. Okay, so if you want to define a function without a prototype, please do so before main, within the same, obviously, the same source code file. Okay. If you want to define it after main, then please write a prototype for it. So what other flavor of functions you might see? So let's say we have another function. And this time we want to return some sort of a value, like an integer, like in main. So you would write int my other function, name it whatever you want. Again, I highly recommend that you you write verbs in here, okay? And then this simply return 10. So simply it returns a value. So, all right, well, let's check it out. And let me just kill this phone here. There you go. All right, so let's call it. Well, how do you call a function that returns an integer? You need, how do you call it? Again, you need to have an integer value that receives whatever you're returning. Aha. So maybe I need int, call it value if you want. And the way we're going to use it is right here. So let me just go over here. We're going to call that function, my other function, by saying value equals my other function. And then to prove that we got the value back, go ahead and print the value. We received this value. All right, so let's see if indeed, oops, spell value better, here you go. If indeed we got the value back from my other function, right? We should get back a 10. Now notice where I defined the function before main. If I didn't, then please write a prototype there. Now we're going to see how these prototypes are going to look like again. And I'm going to cut all of this code here and put it after main. So first, let's just make sure that it works. So let's compile and run. And notice we received this value, 10. Okay? Right. Now remember that value as a variable was declared within main. Okay, so it's a local variable to main. However, its value, whatever you're going to store in it, is whatever my other function returns. And what is it going to return? That one is going to return a value of 10, which happens to be an integer. Make sure that you have a match of data types. So that means value is integer. That matches what my other function returns, which happens to be what? An integer. And make sure that you are actually returning an integer. Okay? Now let's take these two functions again. Let me cut them. And define them after main. And we get to see how the proper prototyping for these functions is going to be done. Okay, so I have my function and my other function. So let's write the prototype for these. So the one is void my function, semicolon. That's it. The other one will be int my other function, and you put a semicolon this way. All right, so let's make sure they're spelled out the same way. So sometimes maybe it's a good idea to copy and paste the actual name of the function if it's too long, so you have consistent naming, and your compiler is not going to sit there scratching its head trying to figure out, whoa, wait a minute, I've never seen that function anywhere, right? So there you have it. So as you can see here, I have two flavors of functions. One that returns nothing, void, and one that returns an integer. But notice none of these two take any arguments or have parameters. Let's have one that takes a parameter, right? So let's do a void test1, and it's a function name, but it will take an integer. Notice here, if it's a prototype, you don't need to formally say what is the variable name. It simply takes an integer. Or it might take a char or a string or whatever data type. So it takes one argument of type integer. So while you're doing what we call function prototype, you do not necessarily need to write it in the long form. So what is a long form? Well, let's define it right here. So I have a void test1, so the function definition will be here, int num. Now, while you're defining the function, you have to literally tell it, okay, it's not just an int as an argument, but what is the name of the variable that you're going to use as your parameter. It happens to be called num. So num now is a parameter, right? And what are you going to do with it? I'm going to display num equal num. Now somebody has to hand over a value to that function. Well, let's see. How do you call a function like test1? All right? So the way you call it, now remember, it has a void, so you do not need a matching variable of a certain type. Since it's void, you can simply call the function, and that would be test1, and supply it with a value. And let's suppose I supply it with a -5. That is an argument. So that means I am calling the function test1 and supplying it with an argument -5 that will be matched to the parameter num, which when the function executes, when will it execute? When you call it, it will simply display what you've handed over or what you passed as a value or a copy of this value here, right? We will eventually have a lesson on how do we pass by value, by reference, and so on, right? So you might be reading that in your textbook right now, but I am simply passing this value, -5, over to num, so num now will be equal to -5, and it should display num equal -5, okay? Well, let's see if that works. So let me compile and run. And sure enough, it does num equals -5. Okay? Now notice the order in which these functions were executed. All of that is dictated in main. Notice the greeting function, which was put in the loop, was done first. Next, my other function, which simply does what? Returns a value. And then we were able to print that value right here in main. Lastly, we called a function where we passed an argument, right? That became a parameter for this function here, right? Num, okay? That we extracted its value and printed it out while we executed test1. So the key now is that this is what we call main, the controlling function in particular. This is like, think of it as the maestro for an orchestra. And all of these are specific, for example, instruments being played. So I will start with the clarinet, then the trombone, then maybe the violin after that. So that's the order in which you're going to call these functions. That is why main has a particular name called the controlling function. So in other words, what happened is you've timed it. Since your program is sequential, you started out calling the my function 10 times. When you were done with that, you went ahead and called my other function. However, you captured the value that it returned, which was a 10, and printed it in main, right? Since you received it back in main to a local variable value that was defined within main. Last, you called the function test1. Now remember, test1 does not return anything. It has a void. However, you need to give it a value between the parentheses as to what you want to do. And once you executed test one, simply the code for test one was within it or defined within that function, which was basically a print to the screen statement. And you were able to print the value that you've actually assigned within main. So it was passed along. This is what we call passing by value. Okay, so a question now is, can you pass more than one value? The answer is absolutely. So for the next video, we're going to review some of what we just done here, and we're going to do various flavors of function calls where some of these functions were defined, where they might take several arguments, and they could be of different data types as well. Okay, some functions we're going to have may simply return a char or a string. It does not have to be always an integer. I'm just using integers for simplicity at this stage. So it could be any data type.